Good morning, everyone. Today is December 15th, 2018, and this is the John Chappell Natural Philosophy Society Science Chat. And you can join us on the web at naturalphilosophy.org. And we are also active on social media. We are on Facebook and also on YouTube as well. If you go to our channel, youtube.naturalphilosophy.org, you can find the recordings for the science chats. So give us a like on Facebook. If you would like to help us out, we are organized on something called Basecamp, which is hq.naturalphilosophy.org. And the rules of conduct for this meeting is that all the participants are to treat each other with respect. And the discussion should be limited to scientific arguments. Please no personal attacks. And we do have some official rules on our website. Also, if you are not speaking, please do not display your video. But if you are speaking, please turn on your camera if you have one. Our upcoming conference is coming up on June 26th. In the University of Washington. So I'd invite you all to think about coming. And we are featuring Dr. Gerald Pollack from the University of Washington as the Lifetime Achievement Award winner. Okay, so last week I had presented a paper which I named The Electromagnetic Wave as an Ordinary Wave, where the basic thesis was that the electromagnetic wave is in fact exactly the same thing as an ordinary sound wave, which is just a compression wave through our particulate matter. And once again, that's just a hypothesis, and the way we do science is that, someone puts out a hypothesis, could be crazy, could be true, and you throw it out there and you just see what sticks. So that was kind of the challenge to me. So it's like, if I just take this hypothesis, like what problems do I have to overcome that makes seem most obvious? So my paper attempted to do that. And we had also presented a previous paper by Ian Cohen, which was also kind of along similar lines, showing that the electromagnetic wave is not really anomalous compared to the sound waves, that there are a lot of things which are comparable on the mathematics between sound waves and electromagnetic waves. But so first I wanted to kind of share with you the results of that. One of the more interesting responses that I got was from Draft Science. So he has his own internet channel on YouTube, and what he decided to do was to play back my conference and then provide a critique of that, which I thought was great, because I invite people to critique whatever I'm doing here. Some people don't like it when they tell you that you're stupid and you're wrong and all that, but me, I love it. So, but so Draft Science has a different viewpoint on what he thinks light is. Specifically, he thinks that it's more of a particle. So he would definitely be more in the particle camp. And so a lot of his comments really aren't, say, attacking what I was saying. Actually, I think we agree a lot on like the nature of light. But but I wanted to point out some of the things and maybe clear up some of the questions or misconceptions he might have had about that. So so one of the things is that you have this difference between people who think that light is like a bullet, which means it does not need a medium. And I guess this is one of his main points, that using the hypothesis that light travels like sound, then of course there must be a medium. But the thing is that if you have a medium, then draft science thinks there's too many problems with having a material medium to consider that. So he thinks that it's much better to think that light travels as like this independent bullets. Bullets don't need a medium to travel from one location to the other, and that's the advantage there. So there doesn't have to be anything particularly to get in the way. So like one of the problems that people would have with this idea that there is actually a physical medium is that you'd think you'd have amazing amounts of drag, right? So if I were to shoot a bullet, it would have to slow down, right? Because it has to plow through all of this material, and all that material has to get out of the way. It takes energy to push that material out of the way. So, how can that be, right? So people will say that this whole hypothesis about light traveling like a sound wave must be wrong because there can't possibly be a medium there because of all the problems that you would get if such a matter material is present. And I am, postulating that there is actually regular matter making up space, which is just a positron and electrons, right? Nothing magical. We know what those things do. If you collide into them, they do take energy, right? So theoretically, yes, anything going through the ether should slow down, just as a matter of losing kinetic energy to the constituents. Right? So I get that, but this is the way I handle that. And that I say that the medium itself is extremely fine compared to matter passing through it, say a bullet. It's so fine that it's much like water passing through a net. So the net is not very dense compared to, say, the water that surrounds it. So the thing is that the matter can pass right by the ether like water through a net. So first of all, it doesn't present that much of a surface area to the passing ether. Now the trick about making it so that it doesn't cause drag is another problem which has to be solved. And the way that I prefer to solve that is that since this medium is made out of positive and negatively charged dipoles, those do have a certain amount of attraction for each other. So I postulate that these particles are relatively close together, much like balls in a ball pit, such that they are almost touching. They have some motion, they're not locked in place, but if they're dipoles, they will align to each other. It's much like if you had a bunch of magnets and you threw them in a bag, they would all align north-south, north-south. So there is some attraction between them. Now, in order to separate those, if you had a bunch, like a handful of these magnets, and you tried to pass something through that, then it would take a certain amount of energy in order to separate, say, a single pair of magnets. So it would be aligned north-south. You try and stick something in between those, it takes energy in order to push them out of the way and separate them. So that is what I believe is the cause of, say, the drag. There, we would recognize that pushing something out of the way would consume energy, and it would have to basically slow down the progress of something else. But I'm saying that that's not necessarily true. That what happens is that as you push through the particles and you separate them, now eventually the particle has to go by, and then those particles have to come back together. And when they do, they are attractive. Once again, the amount of energy it took to separate these ether particles actually has to be returned back to the particle as it passes. So it's almost like the medium acts like a spring, which is alternately stretched and then returned back to its normal shape. So I'm saying that this is actually the source of inertia. So, but this is another thing that you have to explain about space, which is you have to explain, why is it a particle in motion stays in motion, and you have to explain why we get what is called inertial resistance. So, like if I take like an automobile and I place it on an air table, which is perfectly frictionless, and I start pushing on that thing, then you know that you just can't push. Actually, we're getting a big echo here. Someone needs to mute themselves. Let's see. Okay, maybe been someone on the phone there. I'm gonna mute that. Okay. So I was trying to explain what we have to, that we've got this inertial resistance that if you push a very large mass, it takes a lot of energy to get that thing moving, right? Now, what that is this this pushback basically from the material ether. That as you try and accelerate an object through an ether, that pushback that you get comes actually from having to break all these ether bonds as it moves forward. Now, for someone who doesn't believe in the ether, they have to explain that somehow as well. I mean, why is it when I try and push a car on a frictionless surface, it just doesn't go just completely straightforward? And because there's nothing resisting it, right? It should just immediately accelerate as fast as your hand pushes it, and there should be no resistance at all, right? If there's nothing, right? So for a person who does not believe in the material ether, your problem is that you have to explain why is it you get this inertial resistance. For someone who does believe in the inertia in a material ether, then that solves that problem because it provides the material resistance that you need in order to justify this inertial resistance. So you just can't arbitrarily take a mass and just arbitrarily accelerate it. You have to go through this relatively thick ether, and that stops you from accelerating. So the other problem that the non-etherist would also have to explain, which is how does inertia work? So when I fire a bullet, I mean, we know that there's chemical energy in the bullet before it's fired, and that when we fire the bullet, it is released, and when the bullet then flies across the room and hits a wall, we can quite clearly see that there is that chemical energy is then released against the wall, and we can see the energy there. But a philosophical question has always been, where is the energy of a bullet stored while it's in flight? So, you can look up this question. It's kind of a famous question, because if you look at the bullet, it's in the middle of flight. If you were to freeze it in time and look at it, and you could examine it with a microscope all you want, but you could never tell any difference between that bullet and the bullet which is just stationary inside the gun. So where is the energy while it's traveling? So as an etherist, believing in this kind of this spring tensiony kind of ether, which is constantly storing and releasing the energy to anything which is in motion, I would say that energy is actually being stored in the ether itself. The ether being considered like a bunch of springs, and the faster some object is going through, the more tension is on those springs, and the more energy is being returned back to the object. And when the object reaches the wall, all of that tension is then converted into what we see in the destruction of the bullet and the wall. So, but it would be basically when it's fired, energy is stored in the ether, being carried along by the bullet, and then when the bullet has to stop against the wall, all of that energy is then converted into what we see, which is heat and noise and other forms of energy. But that was because it was literally stored and transported from one location to the other using a material ether. So because this is fast physics reasons, like why do you have to have a medium? What purpose does it serve? So I would say the purpose of it serving is to justify inertia and inertial resistance, right? You've got to be able to explain those two things, and those two things are more explainable in terms of a material medium than having nothing. Because if you have nothing, then you have to come up with some other entirely different explanation for why those two phenomena occur. So I believe that that is a reason. So I see, Laura, you raised your flag. Do you have a question or a comment?
Yeah. I just, you make some really important points, especially regarding inertia. So I just wanted to throw out quickly my idea of what the ether is, which is very similar to yours, because I think we both realize that there's something like an electron-positron pair or something like that, okay? So through the work that I've been doing, I've come to the conclusion that, first of all, there's only one ether in my model, okay? Everything is ether, okay? So even matter is ether, okay? So there's three kinds of ether, but it's all one ether. So let's say the universe started, I call it primary ether. Primary ether is inertia. It's one and the same. And okay, I just want to point out that I got this idea from studying superfluids and Bose-Einstein condenses, BECs, okay, because this is what they do. When you cool down a material to almost absolute zero, it becomes pure inertia, okay? So if you try to spin that, it's resisting spin. So it is by definition inertia, because inertia is resistance to change. Okay, so I'm assuming that the universe started out as pure inertia, and then but for some reason something changed. So when you try to spin BEC, what happens is it resists the spin. But if you add more energy and add more energy trying to spin it, at some point there's a phase transition. And this phase transition forms vortex-anti-vortex pairs. Okay, so this is real life. This is really what happens. And so that's what got me to thinking that these vortex-anti-vortex pairs are the electron-positron pairs that we're talking about. And so the reason the BEC does this is to conserve angular momentum. But because it can't spin itself, because it's pure inertia, it has to spin up all these vortex-anti-vortex pairs, and that's to conserve angular momentum. So these vortex-anti-vortex pairs are the electron-positron pairs, but they're sitting in inertia. They're actually loss of inertia. They're inertialess. They have no mass, these electron-positron pairs. When an electron and a positron annihilate each other, they dump all of their ponderable mass into the two gamma rays, and they fall into a sea of vortex-anti-vortex pairs, which are completely inertialess. The inertia in my model, the inertia comes from the primary ether. So there's two phase transitions in the BEC. It's not a terribly long story, but it's a bit long. There's another phase transition in a Bose-Einstein condensate that starts the formation of unpaired vortices. So those would be analogous to charges, positive and negative charges, okay? Because they're not paired anymore. The vortex pairs have to surround them. They're trying to neutralize them, basically, and that's what creates the electrostatic field. So you can think of the electron-positron pairs are lining up like the iron filings line up around a magnet. They line up, and that's what creates the field. So I believe the fields that we experience, magnetic field and electrostatic field, are electron-positron pairs lining up in certain ways to, do a certain job. So that's my ether theory, and I think it gets closer to the truth. The electron-positron pairs on their own can't create inertia because they're inertialess. So inertia can't come from inertia, it has to come from somewhere else. And so I took it a step back and said, okay, there's some substrate that these electron-positron pairs are sitting in, and that's the inertia. That's inertia. So because these things are spinning, when you move a particle through the ether, the angular momentum of these spinning objects gives the matter a little kick. Gives a little kick, like pushing a swing. It's doing it at just the right time to give it a kick to have it keep going. And the universe is always conserving angular momentum. So whatever the universe is doing, it's because of conservation of angular momentum. So conservation of angular momentum is my conservation law. Everything else in the universe that happens because of conservation of angular momentum. That's kind of a long story. That's where I'm going with like the talk I'm giving next week will be the foundation for this theory. So I'm not going to be talking about this next week, but this I have to explain, I have to go back in time and fix a bug, and then we can have the ether back. But that's my take on ether. So I call it primary, secondary, and tertiary. Primary is inertia. Secondary is loss of inertia, which are the pairs. And tertiary is just matter forming. So there's two bangs. The first bang is the electron-positron pairs, and that's what Ernest Sternglass talks about. I don't know if you know his book, Before the Big Bang, but that's what he was talking about. And then the second phase transition is when the matter was formed, the unpaired vortices, the charges, and that's what the Big Bang. So I don't have to even deny the Big Bang. It's just a phase transition. So when matter appeared in the universe, it's just a phase transition. So it's a lovely, nice, simple explanation for the ether, but there's only one ether. It's like there's only one complex plane, and everything, emerges from that one ether.
Yeah, I like the idea that there's only one ether, but this one ether has to explain a lot of things.
Yes, this ether explains everything because there's one ether, but three modalities of the ether. So there's three manifestations of the ether: the primary, the secondary, and then matter. So, but everything, nothing would have happened if primary didn't exist. You know what I mean? So there's one ether, but three modalities. And my ether explains inertia, it explains electric charge and magnetic charge, and it explains matter. Now, what happens is when matter appears in the ether somewhere in space, it displaces the electron-positron pairs, the vortex pairs. I call them vortex pairs. So I'm going to say vortex pairs from now on. So it displaces these vortex pairs and creates a gradient in the secondary medium. And that gradient is curved space-time. It's basically gravity. So the cause of gravity is the displacement of this secondary medium, pushing so matter displaces the electron-positron pairs, and that creates a gradient. And all forces are gradients. So as soon as you have a gradient, you're going to have potential for force. As soon as you have a hill, you're going to have something roll down the hill, right?
Okay, looks like we got Michael's raised his flag here. So
okay.
Michael, you want to say something?
Well, when she suggested that an etherist can go along with the Big Bang theory, in my ether model, you don't, because in my theory, you have a basic ether which is composed of vibrational units, which are all the same. They all come from a first causal mechanism in which universal oscillation became a universal vibration, and the ether arose there. And then as far as Big Bang goes, then you have, in my model, you introduce the idea of creation, of projecting electrons into a virginal ether, which is unquantized. And by doing that, you set off a chain reactional quantization, which is creational, and it's designed so that we'll have magnetic a quantized macrocosm rather than an ether macrocosm, which would be less magnetically stable. And so with a more magnetically stable universe like we have, it would eliminate the instability of the magnetic instability of the ether macrocosm which preceded it. So that's another way of looking at it. I mean, that's another ether model, which makes sense in itself.
Yeah. Yeah, but the model I'm suggesting has precedence. Okay, I'm hearing a bit of an echo, but who am I echoing from?
I'm not sure. I don't hear the echo myself.
Okay, so the ether model that I'm proposing has precedence in that this is what happens when you cool down a material and bring it to almost absolute zero and then bring the temperature up again and or try to spin it. You get, the Bose-Einstein condensate when it's almost at absolute zero is not quantized. It is just a blank sheet of paper basically. And then as you spin it up, the vortex pairs form, and that's the quantization. So I already know that the universe can do this, that it does this, because we do experiments all the time. I don't, but I've read lots and lots of papers on this, and this is how it works. These vortex-anti-vortex pairs emerge from the blank sheet of the Bose-Einstein condensate, which is not quantized. It's one wave function, so it's not quantized. So my ether model has precedence in reality and experimentation, which is why I went with this model, because I can point to something and say, look, the universe does this, and the universe is super, super simple. Okay, the universe doesn't do one thing somewhere and something else somewhere else. This is how it works. So this is why I'm proposing the one ether but three ether modalities, because this is the Bose-Einstein condensate. It starts out blank, then you get the vortex pairs, then you get the unpaired vortexes, and they emerge. They are created, yes, but they're only created because of conservation of angular momentum. They're just as the universe spins up. Now, why is the universe spinning up? I don't know. But each phase transition, and there were two main ones, where the vortex pairs were formed, and then where matter was formed. So when matter was formed, that's, we perceive that as the Big Bang. It's not a bang.
Looks like Michael's got another comment here. He's raised his flag. So when you're responding, please try and keep your comments brief and breathe, so that we can respond to other people who are raising their flag.
Well, in my model, there is some experimental justification for this kind of view, which should be a quantum entanglement. And in quantum entanglement, I propose that there are two quantum units which remain perfectly connected even when they're separated, is due to an ether matrix, which is composed of individual units, which and the energy of one ether region causes an alignment and entrainment and other linkages which form the quantum unit, so that the quantum unit is made up of individual ether units. And so there's all the linear forces of the vibration makes a perfect model for quantum entanglement. So there is some experimental justification for my kind of ether model.
Well, I think that we could sit here and debate. If I started also joining the debate about what the ether is, we could probably sit here all day long. Although, to getting back to the topic here, which is basically, for all of us etherists, we have to contend with the people who think that there isn't one. So rather than getting into the details of my, yours, or Lori's ether, do you have any comment about, Draft Science, who doesn't believe there's any ether at all? He doesn't see any need for it, is what his comment is. Do you have a response to Michael saying that there is no ether, there is no need for an ether, it's just superfluous, and that's how he would respond to all of us?
Well, you can ignore first causal mechanisms, but in my model, you do have a first causal mechanism. You don't just say, oh, well, there was a big bang, we don't know where it came from or how it happened or anything like that. But in my model, you had a universal oscillation, which transitioned to a universal vibration of elemental units, which are all uniform, and which form a matrix, which is a medium, and which also is vibrationally self-resonant with intermittent spaces in between the units to allow for vibrational motion, or originally from oscillational motion. Yeah. So I think my model makes an awful lot of sense, and you can take a different perspective from experimental science, empirical quantum mechanics, and all that, but it's a different world altogether. I mean, the ether in the background it's a different world that we can't apply our empirical constructs and just simply apply it to an ether. It's different.
Yeah. I think we're talking about exactly the same thing, actually. After what you just said, it sounds to me like what you call your oscillator resonance or whatever, that's my vortex pairs because they're spinning, and that would be generating the resonance. So I think we're actually talking about the same thing. We're just using different words. So I think we actually have the same model. We're just, articulating it different. That's, what do you think, Franklin?
Well, I'm trying to just break out the difference between the people who believe there is an ether and the people who don't, you see? It's like, everything that Michael said would fall on deaf ears to someone who doesn't even think there's even a need for an ether, right? They just say, well, specifically in regards to the behavior of light, which is what we were talking about. Specifically, draft science does not believe that light needs to travel through a medium, and he really doesn't even believe that it's a wave. In this particular view, light is literally like a bullet. Now, one of the other criticisms that he has is that, because I say that as well, I say light is like a bullet. It travels with a finite amount of volume. It has, a beginning and end. It's like this pencil. So he says, well, if you're going to go all that way, then why don't you just say it is a particle, right? Because that's what particles are, right? But I still maintain that that it's not any material particle like an electron, but rather that it is still a wave in a medium. And light in particular is usually just a one-shot wave, like a bugunk. That's what I feel that kind of wave is, which would give it the particle-like properties it needs in order to travel like a bullet. And that, bullets travel straight line, right? They have a fixed diameter and length. And so this is his argument that, why do you need to make it a wave? Why don't you just say it's a particle? Well,
what if it's neither? What if it's something else? Okay.
Well, it could be something else.
I have a third option. It's an electrical signal. It's an electrical circuit. So instead of, like, how we draw a voltage change as a sine wave? Okay, we've been drawing light. We've been drawing light as sine waves and cosine waves, right? And even, like, I know someone who's an atomic physicist, and he actually thinks that light travels through space up and down like a sine wave, because he doesn't care, because he's an atomic physicist. He doesn't care what light's doing. So this is what he was taught, okay? So, so this is the direction I'm going. So I work on a paper right now which models light as an LC oscillator, as an oscillating circuit. And when I did that, I got some really interesting results. I was able to retroduce the correct impedance of free space by doing it this way. So it may actually be more like an electrical circuit and less like a wave, and certainly not like a particle. Far, like, so charge is not like a particle. When charge goes through a circuit, it's completely inertialess, right? When you turn on a circuit, the charge flow, whatever charge is, and I don't know what it is, flows through the circuit without any inertia, right? When you turn on the switch, voltage goes to the high, or the current flows right away. There's no inertia. So, I believe it's my inertialess particles going through a circuit, because it's completely inertialess. When you turn off a circuit, the electrons don't bump into each other. you know, because they have inertia. Electrons have mass, so they have to have inertia. But the circuit, they don't, you know, bump into each other in the circuit, at least not as far as I know.
Okay,
So,
I think Bill's got a question.
Okay.
Go ahead, Bill. You raise your flag.
Experimentally, we find that the electromagnetic field consists of two components, transverse and longitudinal. Transverse has the velocity c, and longitudinal has no upper limit to the velocity. How do we coordinate those experimental results with these ideas of the ether?
Well, if these dipoles would in fact create electromagnetic fields, they actually are the electromagnetic fields, and so it makes sense that if the ether is filled with dipoles, which are the vortex-antivortex pairs, electron-positron pairs, that whatever is happening in the ether is more like an electrical circuit and less like a wave, because we don't call electrical circuits waves. So if these are little dipoles and they're hanging out in space, and they can be polarized, right, by putting a magnet in the field, or, you know, by even just matter going into the field, it slightly polarizes the medium around it. It seems to me that would explain a lot of things, including electricity, including how current flows, if current is in fact these electron-positron pairs going through the wire. So that could be what's flowing through the wire, and they would be polarizing the medium because they are the medium. So kind of, I don't know. I haven't worked it all out yet, but it's really, I'm really leaning towards it's that light is not a wave and it's not a particle. It's actually more like an electrical circuit. And that,
it looks like Bob has raised his flag. Although I have seen this, what you're talking about, Lori, the light wave modeled as actually an inductance capacitance chain.
Yeah, exactly.
If you look in the internet, you'll see that. So Bob has a comment.
Yeah, Bill, can you provide any references on these experimental results that show that there is no upper limit to the longitudinal component, and anything about the experimental results showing that electromagnetic waves have a transverse component?
If you look in my book on the universal force, volume 1, you will see that the empirical laws of electrodynamics, Gauss's laws, Faraday's law, Ampere's law, Lorentz's law, and Lenz's law, when they are solved simultaneously, you obtain two solutions. One's longitudinal, one's a transverse. And because those laws are all built on experiment, that means that all the experiments in electrodynamics together require a longitudinal and a transverse form of light. But there's one other thing that's important, and that is Arthur Compton, who received a Nobel Prize for showing the wavelength of the electron. His work showed, and particularly with his last graduate student, Winston Bostic, that the electron is composed of electromagnetic fields, and charge is merely an approximation to try and approximate mathematically the structure of the field. But that charge is not something that exists separately, and charge is the electron is composed of the field, and it is not the source of the field. It is composed of the field. It is a vortex in the field. And so what we have is, in the different approaches we're taking, we're using a little bit of this and a little bit of that, and they all have some relevance. But the question is, what is first? What comes first? Is it the particle or is it the field? And what Winston Bostic and Arthur Compton found was that it was the field is first, and all vortexes in the field are called solitons, make up your particles like electrons and positrons, but vortexes can get together in very specific geometrical combinations and produce all your set of elementary particles. So
okay, looks like Lori's got a comment
Yeah.
here. So when we're
Yeah.
when you comment, I know everyone loves to give lengthy explanations of their own theory, but I would just ask that you try and control yourself and try and just answer the questions.
There are no questions though, so if I was asked a question, I would answer it. Okay, Bill, I really like your book. I just wanted to say, Bill, I read The Universal Force, and you got a lot of good stuff in there, especially the idea about the solitons, which my unpaired vortices that I talk about in my ether would be solitons. Okay, so that's really interesting. In my model, the field is the electron-positron pairs, so the solitons, the particles, don't have the property of charge, so I agree with you about that, and that's really good. I probably got that idea from you, actually. So I just want to say, hello, thank you for writing a great book.
Well, thank you for your compliments.
2 thumbs up for Bill, right?
Yeah.
But getting back to what the question about what is the evidence for, say, transverseness, that is one of the responses that I got back, because I specifically asked for, give me an experiment that shows me the shape of the electromagnetic wave as having some kind of measurable, time-varying component as it travels, right? So I did get this one response here. Let me share it with you. And this is called a paper called The Direct Measurement of Light Waves. So this, in fact, may be an actual attempt to do what I was suggesting. So this paper, what they're doing is that they are sending a pulse of light, so it's shown here in red, through their detector here. And what they're doing is that if you think that the light wave consists of a electromagnetic field bearing, then you would think if you put an electron in this field that you would see it wave back and forth. So in this bottom picture, it would show like the strength of the electric field, what you would predict as it was traveling by. And if you put an electron in that area, you should see that electron actually waving, or at least having a much stronger attraction at, say, this point. There's this maximum here versus the minimum, because they know what the wave form of the light pulse is, and it looks like this. It starts low and it gets big and it gets slow again. This is what they've measured as a light pulse. So the way they did this is that they put this in a gas, and what they do is that they shoot a high ultraviolet a pulse through that to basically ionize the gas, and then they send the light pulse through, and they measure what happens to the electrons, right? So when they do that, they do get something which looks like this, and in this picture here, and they do seem to get a correlation. And this is all made possible by these attosecond accurate timing and sensors, because before, this kind of measurement was basically impossible to do. The instrumentation just wasn't there. But one of the innovations with this experiment is to show that you can measure these femtosecond delays and actually get measurements out of instruments like this, which is quite amazing. So, but they do seem to have this correlation between what they think the what the electromagnetic wave looks like, and what we can detect it doing to nearby electrons. So that is one possible direct experiment showing that there is at least a time-varying electric field, not electromagnetic, just electric, because this is all this is measuring, just measuring the electric field of a light pulse traveling in free space. So, Bob, you had a comment?
Right. I'd like to point out that, well, I think there's a difference between electromagnetic waves and light. They're composed of the same thing, but light is a soliton. It's unidirectional. Electromagnetic waves in general, radio waves, higher frequency waves, is omnidirectional. So there's a difference, and be curious to read the paper and see if they're specifically referring to light, or if they're talking in general any electromagnetic wave. And that's the same area that I was going with as far as experimental proof of transverseness or longitudinalness. Are they using light, or are they using electromagnetic waves?
Well, they're saying they are their apparatus allows complete characterization of few cycle waves of visible, ultraviolet, and or infrared light. So they are using visible light.
But it depends, yeah, and it depends on how it's generated. If it is generated by a transition, a quantum mechanical transition, and for example an atom, then it's like a photon, or it has a unidirection. But if it's a charge and you're wiggling that charge, there's no other charge around, so it's not a quantum mechanical system, then it's omnidirectional. And that's the distinction that I'm trying to make, and to see what they're doing in this experiment. If they are generating the light from some atoms exciting and de-exciting, that's all about light, and may not be exactly the same as lower frequency oscillating of a charge.
What they're saying here is that with the generation of waveform-controlled intense few cycle light wave pulses, and they have a reference to that, and it's a successful application to producing single 250 XUV pulses. So whatever their light wave is, it kind of looks like this picture here. That they can recover the waveform here, which means it has a peak. It's not a single say wave, which is what I would expect for light generated type light, because I agree with you that there's this difference between light that's generated by atomic processes versus radio, but maybe this pulse occurs even in the case of a single what is normally called a soliton. I know Bill is using soliton a different way, but soliton just means single wave. That maybe what they're looking at here is in fact also a soliton, but that the surrounding medium kind of spreads it out like we see here. But I mean, there's a whole question as to how does this thing actually get generated. But they do say they're dealing with visible light here. So to the person who submitted this to me, my question to them was that, okay, you've got this correlation between the pulse and what you're covering back as electron movement. But my question was, do you know that whether that was say movement in a specific transverse direction? Because in accordance with the standard mainstream view of this thing, this peak should only exist in say one plane, I guess. So if you were to polarize the light pulse and then put the detector at say 90-degree angle to what is shown in this picture, you would predict that you would get nothing, right? And then that would be more convincing that the electric field, not only is it there, but it is in a particular plane that it could be orthogonal to this magnetic field, right? But I didn't get a response. The other thing that I thought was that is that instead of this being the transverse wave, maybe this is just a general compression, still a compression wave, and the compression wave will just generally push the electrons out of the way as a wave, and you would see this pattern, no matter which way you looked at it. So this experimental result could still be perfectly compatible with the idea that this wave is going through a compression medium and it's just pushing the electrons out of the way, and it doesn't necessarily indicate that it's an electric field pushing these electrons. Maybe their electrons are sitting in a sea, the sea is being pushed aside, therefore moving the electrons, right? The other point would be that we know that the light wave, or the radio wave specifically, has exactly this kind of behavior to the electrons in a receiving antenna. So we know that if I have a transmitter and it's sending out this particular signal up and down, we know that you put up an identical piece of metal to your transmitter. We know that as the wave hits that antenna, it also causes the electrons somehow to have this exact same motion, which is what he's measuring in this experiment. So this is just like a really, really complicated and expensive way to do exactly what a radio receiver antenna would do, which is it just allows the electrons to motion in the field. So it's just quite clear that electrons will wave in the presence of an electromagnetic wave, and this is just a much more fancy way of saying it does that. I'm not sure that this necessarily says that the reason why it's doing that is because of a changing electrical field that's attracting and repelling the charge. So Bob, you had another question, and then Lori?
A comment. I have a couple of slides on the traditional way that they prove that electromagnetic waves are transverse, and my reason why that argument is false. If anybody wants to go over that, I'd be willing to show those 3 or 4 slides. Yes, math. So don't know that it'd be a lot of interest to a lot of people here. But it's available if anyone would like to see that.
Well, how can you show that light is not transverse with math? I'm not sure how you would logically do that. This is the problem I have with a lot of these things about trying to prove stuff with math, right? It just...
I'm showing the traditional way to prove that electrodynamic waves are transverse, and then I show the fault in that argument.
I think you actually showed that last week, or the week before, I think.
Maybe. I recall doing the derivation of the wave equation and problems with that.
Yeah, that's what we did, I think.
Yeah, I don't recall the quote-unquote proof that the waves are transverse. But where there's not a lot of math-oriented people here, it's okay. You know, I don't have to present that.
Yeah, it'd just be a bunch of Greek. So that's what people are doing. They're like sending me like, what do you think of this MUE0? It's like, well, I don't know what you're talking about. What symbols are you talking about, right? So, but he was talking about the electric and magnetic fields, right? It's like not everybody uses the same nomenclature, right? So you just can't send me your equations, and I have no idea what your subscripted variable means at all. So I really can't comment on that because I got one response like that. So it's like, what do you think of my equations? It's like, it looks literally like Greek to me. It might as well be in some hieroglyphics. It's going to mean nothing to me. But that was just my little rant against math stuff. But I also got another response here. So that's an experiment that tries to measure the electrical component of the EM wave. So just, I'm showing I'm fair here. I'm showing that, the responses that I've been getting. So this article is about...
Oh, wait, I had something to say.
Oh, go ahead.
Before we move on, right? I don't want to go on to a different track when we're on this track. So if there's a medium, okay, first of all, I want to answer your question that you asked a long time ago. What would I say to Daft, what's his name? Daft Science, I know.
Draft physics.
Draft physics. Okay, so what would I say to him? Basically, what I would say is, if the math is greatly simplified by having an ether, then the ether model is better. So if I can come up with a set of equations that explains everything and it's very, very simple, this is what I'm trying to do, then the ether model is better if it simplifies things. So yeah, it might not be an ether, but if he can't explain it, if his math is too complicated, and I'm not really that smart, I like things to be simple. I wanted the simplest solution. So I, according to Occam's razor, would say, if my model has less equations, let's say, and less variables and that sort of thing, then it's a better model.
Well, I think he would say that, his model is much simpler because he doesn't have to have any math, because his particles travel through nothing, and so there's nothing to explain about nothing. You
Yes.
just have light, and specifically he's talking about the propagation of light through space. And so I don't know how he deals with some of these other issues, but as far as light traveling through, it's much simpler to think of light as actually being like a bullet. So that's what he'd say, and there's no math involved around a bullet.
No, but what I'm saying is, I'm not just doing the propagation of light, okay? I'm coming up with a whole model of the universe. So if my ether model of the universe can explain everything, including magnetism and potential fields and the nucleus of the atom, and if it can explain all that stuff with fewer equations, right? Not just the propagation of light, because he, like you said earlier, he has to explain inertia, which I don't think he can do. So if I can explain inertia and everything in the universe, I'm talking about how matter was formed. Like if I can answer all those questions and have the least number of equations and if I can explain it to a high school kid, then I'm doing better, I think. And that's I'm hypothesizing that I can do this, but this is what I'm trying to do. This is my goal.
All right. Well, Draft Physics will probably be watching this anyway, so maybe he'll have a response to your response. Okay. So, but I'm trying to represent his standpoint, because I believe that in order to discuss something with someone sensibly, you really have to be able to state their stance and have it make sense to you. If you state their stance and it doesn't make any sense to you, then I would say you don't understand what they're thinking, and therefore you will not be able to respond back to them in a sensible manner, because you will be on just a completely different plane than they were at. I think it's very important that you be able to restate your opponent's views the way they would do it and understand why they would do it. Therefore, you have a much better basis of refuting what they're saying. But in any case, I'll bring up this other article that I received, that I don't think I received this one, but I looked it up based on the existence of that other experiment, which is to try and find something where they're actually measuring the electric and or magnetic component of the traveling light wave. So they're trying to put the magnetic back in electromagnetic. So they have a standing light wave with magnetic blue and red electric peaks, generating a photonic cavity as the light bounces between two reflection points. So this is the experimental setup here. And let's see, how did they actually measure the magnetic? They managed to directly isolate the magnetic field effect. They worked with photonic crystal microcavity. And they basically, let's see, they have these metal rings in it, and that they get like a resonance off of it. It's like playing a guitar. And so this ring is basically resonating inside the magnetic field, and they can read that off, so they can presume that this resonance that they're getting is being caused by a time-varying magnetic field. So they're using this tip to probe the magnetic field that's propagating in their light. So they feel that they have detected this time-varying magnetic field. Okay, although that's a lot harder to understand than measuring the electric field here. So it's a little bit more confusing than that. Okay, so they use a metal ring to detect the magnetic field. Okay, so that's another example of someone who's directly trying to measure the magnetic field of an infrared light cavity. And I'm not exactly sure what to think of this result here. It's kind of a fairly convoluted way of doing things, and I don't see them. I mean, if they were to move their probe up and down the standing wave and show me, you know, a sine, they can recover a sine wave kind of signal as they move it back and forth that corresponds to the wavelength, but I'm not sure they did that. So because of how complicated this is, you know, it's hard to interpret whether they did what they're saying they are. But they are using light, infrared, and they are using magnetism. This is clear. So, but those were two of the more interesting responses I had gotten back from my challenge, which was to directly measure the time-varying magnetic and electric fields in a moving light wave, a live light wave. So experiments like that do exist. So, and I thought that was one, like I said, one of the more interesting things that I found. Now, getting back to draft physics's problem. So we discussed the problems with, you know, having an ether versus not having an ether. The other problems he has with a material ether is that if such a thing existed, then obviously it would have gravity, right? So his question is, well, why don't we see the gravitational effects of all this ether around us? So he thinks that just makes no sense at all. That, you know, if there were gravity, we would certainly there would certainly be effects, and so he dismisses that because we don't detect any gravity. We only detect gravity from material objects like the Earth, say. We don't detect gravity from like empty space. Okay, so the way that I respond to that is that, well, you're assuming that you know what the origin of gravity is, and you know, certain theories of gravity, say like mine, say that gravity is caused by an imbalance in the electric charges. And you know, mine in particular says that, you know, the Earth is has a net positive charge, and that net positive charge is what causes gravity. Therefore, if you had substance like a positron-electron ether, which was perfectly balanced, then there would be no gravity coming from it because it would not emit this unbalanced electrical field, which we call gravity. Now, assuming that you don't believe my gravity theory, which you may not, then that theory may fall on deaf ears. So the other consideration is that if you are surrounded by a sea of this ether, which is gravitational and creates its own gravitational field, and it actually pervades everything and surrounds everything, then I would say it would pull evenly in every direction. So my question to draft science would be is that if you expect it to be gravitational, then what kind of effects would you expect? I mean, I wouldn't expect that, you know, I would feel any tug from anywhere because it'd be totally surrounding me. It'd be pulling the same every which direction. So even if it was the largest source of gravity in the universe, we wouldn't notice it because it pulls the same. So even if you completely ignore my own conception of how gravity works, even if you start with the hypothesis that this stuff is gravitational, then still that doesn't lead to a problem, right? It being gravity. The other problem might be that if it is ordinary matter, then it is in fact gravitationally attracted, and so it should be like the atmosphere of the Earth, and it should be gravitationally attracted to the Earth and be more concentrated near the Earth than in space. Right? So that would be another consequence if the ether is made out of ordinary matter, that it would in fact be denser near gravitational objects. Now for me, that's actually a feature and not a bug, because that's needed in order to explain the phenomenon of light bending around gravitational objects. And that isn't due to the warping of space and time. That's due to the ether actually becoming more dense around large objects. And because the density changes the refractive index, just like it does in water. And therefore, what you call gravitational lensing is actually literally lensing, that you have light waves going through material of a different refractional index and causing the actual bending. This is what causes light to bend. It's not like it's attracted to gravity in any way. It's just going through a substance which is thicker than what it normally encounters in space, and that was what causes it to bend. So, but this is another challenge to people who don't think that space has a material substance, which that you have to then explain how gravitational lensing works without there being anything to do the gravitational lensing, right? So that's another challenge to people who think there is no ether. You have to explain how gravitational lensing works. But it works very easily if it's just a compression of the whatever you think the ether material is. So once again, this argument of gravity is it's not a bug, it's actually a feature. It allows me to explain a lot of other phenomenon that you would otherwise have to come up with some other completely different mechanism to explain. And like Lori says, is that it's like, yeah, you can explain light as a physical bullet through empty space, but you have to explain all these other phenomenon that come along with that you would have to explain in a completely different way, right? So with an ether, you have a physical medium you can play with, you can explain all these things like, what is the magnetic field? Well, how is the electrical field propagated? How does inertia work? Why do materials have why do materials have mass? How does it, stuff like that. There are a lot of things you have to explain. So, Michael, you had a comment.
The way my model of ether would explain gravitational lensing would be that you have foci, stellar energy, and the distant star, and you have the sun, and then you have the moon in between. But the high energy areas have more etheric alignments and entrainments and linkages, and this creates a focus of energy. And making an analogy with quantum entanglement, there would be through the intermittent space, as vast as it is, there would be analogy of the photonic energies between the sun, our solar region, and the distant star. And when the light beam reaches the area of our sun, it again encounters the high energy photonic medium, and it affects the pathway of the light. And the resonances are entirely different from what they are in space, and so the path of the light would be observed to be different as it comes into our solar region on that basis. And as far as gravity goes, my model can explain that too, because if you have a vibratory ether, you have to have intermittent space for the vibrations to occur, and then you would have an elemental ether unit continuum between solid bodies, and so the space a space in between two solid bodies, or you might call it an auric space, would have more of a tightening of the ether there, because there's a resonance between the bodies and the elemental ether units in the space between the bodies. So it's like an area of space where there's more energy, and the space of the vibration between the vibrating units creates a tightening of the ether between the two bodies, and so that's what my model of the ether would explain gravity.
Okay. Although I would have to admit that I didn't understand the word you said, but it's good that you get your theory out there. Okay, but getting back to draft physics's objections. So, like I said, draft physics's question is, why do you have to have an ether? It doesn't serve any purpose, right? But I would argue that it does serve a purpose, because there has to be something to explain, say, the magnetic field. The magnetic field is also existent in so-called empty space, and if it's so empty, how can that be represented? At least if I put a dipole in there, then I can represent the magnetic field by a vector direction of the dipole, and the number of dipoles that are aligned in that vector direction could be a magnetic field. At least there's something physical. You don't have to necessarily accept that explanation for the magnetic field, but there has to be something physical in the vacuum in order to represent the vector direction of these fields. So I would say that the ether serves a very big purpose that completely empty space cannot possibly fill, right? You can explain lights as little bullets, and although you haven't explained what these bullets are, and that's another big thing, that you must be proposing that the photon is some other different matter particle that science has yet to discover, basically. But I think it probably has more characteristics of a wave than that a bullet can't explain. It's one of the things is that if you take a light wave and you pass it through materials of different refractive indexes, it will come in at a certain speed. It will slow down in the denser object, but then when it emerges, it will speed right back up again, right? Now that slowing down and speeding back up without adding any energy is not something bullets generally do. That's generally something that only a wave can do through a refractive index, through refractive material. So in that way, this is one of the reasons why I would say I would vote in favor of the material versus the non-material ether. Now, one thing that he does explain is that light comes in quanta, and each quanta contains the same energy. So literally the formula is energy equals Planck constant times frequency, E equals HF. And if you understand that literally, frequency is cycles per second, then that just means that Planck's constant is the amount of energy delivered in each cycle, and that the only reason why higher frequency has more energy is that it delivers more Planck's constant's worth of energy over the same second, right? So, it delivers 100 packets over a second or delivers 10 over a second, right? So we would be in full agreement about that. But like again, once again, his argument is that if you can accept all that, then, why not just make it a bullet? And it's like, well, it could be a bullet. I'm not disputing that, but you would have a harder time explaining all these other things. Another thing that he mentioned, I did mention that you could create these magnetic waves and you could transmit a significant amount of energy. So for those who doubt that, Google the magnetic resonance and MIT, and that will bring up an experiment where they use these magnetic resonance loops to transmit light across like 5 or 6 feet to light up like a light bulb, right? So transmitting a significant amount of power through magnetic resonance. And of course, the problem with these situations is that you waste most of your energy by most of the energy gets lost. It just goes out, and it's not very efficient. So we can do it for like, say, very short distances, charging our iPads, and like these inductive chargers like we have for our cell phones nowadays, where you don't have to plug anything in, kind of work on the same principle here, that you send a magnetic type of wave from like a transformer, and that can be recovered as a reasonable amount of power. But those are not what we call EM waves, right? And I believe that those waves are not as durable as EM waves. For example, you couldn't create a practical radio transmitter out of it. They do, but they drop off like 1/r cubed versus 1/r squared, and that's actually a very, very big difference in the amount of energy you can recover. So an EM wave will travel very, very long distances, which is what makes them practical for radio transmissions, right? Versus magnetic resonance type of things, which will only travel like, say, 10 feet practically. And they don't make very good radio receivers, right? Now, I did bring up, let's see here. I had brought up my mechanical analog here for the polarizer, so which was this thing here. So he had a couple criticisms on that. Now, I would agree that perhaps this is not the most accurate model for a polarizer. I just kind of made this up. So his points were that this polarizer kind of depends on its thickness to do the job here. It's the thickness which prevents the light waves that are coming in from odd directions from coming through. He would more think that a polarizer is more like jail bars, right? So you don't need the thickness in order to get the polarizing effect. So that might be true. I mean, one of the things that I've seen in polarizers is that they have a thing called grid polarizer, and what this literally is literally jail bars, because all they have is just very, very very small wires running up and down, and that alone is enough to polarize even light waves. So you don't need, I don't know, say the thickness, although light waves compared to, the thinnest bar you could possibly put up still might look like fairly thick compared to nanometers light waves. So I'm not completely giving up on this, but I just wanted to point out that they do have something called grid polarizers, which polarize literally with just wires. And so the theory is that as the light wave comes through, because the electrons on the wires are mobile, what happens is that they say it acts as if it were a silvered surface. You know how light is reflected off of a mirror? That's because the sea of mobile electrons in the metallicized layer of the metal, because they're free to move, they are reflected. So what the grid polarizer is supposed to do is that since the electrons are free to move only one direction, it has a very preferential reflecting ability. So any light waves which come in, which cause the polarizer to cause the electrons to move in the direction of the wires, those are absorbed, or they're reflected, basically. To the light wave, that looks like a mirror, so they bounce off, right? Only letting the waves which are going basically in a perpendicular direction through. And that's actually kind of the opposite of the typical wave through the picket fence idea, because actually what it's doing is it's actually filtering out the waves which are in the direction of the picket fence, right? And it's letting the ones that go this way through, right? So this is like completely contradictory to the usual view. And I mean, I've seen diagrams of this where they have like basically radio transmitter, and then they have similar wire for the receiver, and they have this grid polarizer through it, and it completely blocks, like if everything's vertically oriented, it completely blocks all that vertically oriented stuff. If you turn the grid polarizer 90 degrees, then all the waves get through, right? But it's interesting that basically just a conducting wire can be used to do the polarization. So I would have to admit that in that way, that it seems to indicate that that there is some electrical component to what's traveling through, which would be kind of hard to explain if it's just a kind of a compression wave that's traveling through space, just as if it were sound, right? So that's a problem. The other problem that was brought up was that he was saying that, I'm saying that light waves are coming through like every which direction like that. So his argument was that that's ridiculous because all light waves travel in completely straight lines. They're not going to be traveling this way and that way. If I had a laser, then they would all come just straight through, and there would be, none of this stuff, right? Okay. So I say that would be true if you were looking at a laser, and that was the only light source in the room. You would only see them coming straight through, right? But that's not what we are generally talking about. So when I take a polarizing material like this, and I put light through it, it's not getting light from just this one direction, as if it were coming from a laser. If I did have a laser, it would. But it's actually getting light from being bounced down from a keyboard. It's getting light bounced down from the ceiling. It's getting light bounced back from me. One way to prove this is that if you've ever seen a pinhole camera, you just put one little teeny little hole in a box, and then you look in the box, and you can see the entire scene. The entire scene has somehow made its way through that tiny little pinhole that you made in the box. And that's because the light is actually coming from a cone, a spherical cone, surrounding the entire opening, right? Light is, in fact, coming from all directions into that pinhole camera and ending up, shooting straight to all the points. So it can reproduce the entire picture from basically tiny, tiny pinhole, right? So that's what I mean that normal light coming from normal directions in normal rooms does in fact come from every possible direction, right? So that's what I mean by light coming in every possible direction and it getting blocked only, and everything getting blocked except for the stuff that fits through the slots. So, but even I would admit that okay, that this may or may not be true. It's just one way of thinking about it, and one way of thinking about how polarization works. And he did have this comment that I said that this was the only way it could work, but actually I never said that. So just want to make it clear that no, this is not the only way it could work. I just said that this was a fully mechanical explanation, right? That's all I mean. It can be demonstrated with mechanical things, pencils and boards, right? So fully mechanical, right? It's not the only explanation, but I just wanted to make that clear since he seemed to get into a huff about me saying that, that I thought that was the only way, and I didn't say any such thing. So, all right. So what other ideas were here? Okay. And he does have this idea that you can't tell the difference between a proton and a positron. And I think scientifically that's not true. If you put a mixed beam of protons and positrons through a magnetic field, you would see the protons deflecting at a much lower rate than the positrons, and in fact, you could separate the two. So if you think that protons and positrons are exactly the same thing, then how is it we can separate them, right? I think the evidence is that we can separate them, therefore that gives them definitely different properties and different names. They are in fact not the same thing. And mainstream science would say that the proton is like 1,800 times more massive than the positron, which would seem to be a pretty big difference. And then in regards to circular polarizers, so I was looking at this question about, well, what exactly is a circular polarizer? I'm still not 100% sure about how that works, and that, you know, I challenge someone to say that, okay, if you had a circular polarizer versus a regular polarizer, could you tell the difference? Now, it seems that circular polarizers are used in digital photography specifically because there's apparently a polarizing element inside the light meter of an SLR. And if you put an ordinary polarizer on an SLR and you twist it at just the right angle, it will cause your polarized light meter to register 0, right? Because all the light would be blocked, right? And then you would take a terrible picture because the camera would think it's completely dark outside when in fact it is not, right? So this is where they use a circular polarizer, where no matter what orientation this polarizer is, it still does its polarization job, apparently. I'm not quite sure how it does that, but it doesn't affect the polarized element for your light meter inside your SLR. Therefore, you can turn it every which way, and it never turns down to 0. So that's some evidence that you can tell whether the circular polarizer in the path. Another interesting thing I found out was that they use these circular polarizers in these 3D glasses because if you used just regular polarized glasses, that if you tilted your head like this, then that would throw off the exact 90-degree crossing with what's going on with the screen. So you go like this, and then you'd lose the polarization effect. And that when you use circular polarizers, you can do this. That you can tilt your head, and still it maintains the polarization effect because it's not relying on the 100% the 90-degree cross and how that works, right? So that's another interesting thing, and I was playing a little bit more around with my polarizers and how they work and what the differences are. So like this is your 3D glasses, and this is the 1/4 wave plate, and this is an ordinary polarizer, and they actually sandwich these things together to make this here. So now what I'm seeing when I experiment this in front of my screen here, so the polarized light comes out of my LED screen because it's got a polarizer. So with my circularly polarized glasses, which means I have the 1/4 wave in front of the regular polarizer, so I can kind of twist this around and it gets a little bit dimmer and brighter, but it doesn't go away like it would with the regular polarizer. So I can kind of see that effect that you have polarized light, it's coming through the 1/4 wave plate and then going to the regular polarizer. Normally, if I tilted it like this, it would become completely black. But with the 1/4 wave plate in place, I can see that I still get the light. I mean, it diminished a tiny bit, but nothing like it would be if I took away the 1/4 plate And then when I rotate, I can see it goes completely black. At that rotation, it's completely black to me. And then it becomes totally clear that way and completely black. So, but with the quarter wave in place, I can see through it. It's reduced, but it's not as bad as it was before. So, once again, that's kind of bizarre behavior. I have yet to really figure out what's going on there and whether this really does have something to do with electrical effects. When doing some research on the polarizers, what they say is that there's a crystal here, but it's been doped with like iodine or something. So it does act like the grid polarizers, and that effectively it creates a very fine spacing of conducting wires in the Polaroid material here. So that's another thing I learned from my responses and looking at that. Now, another interesting thing I wanted to show you was that I had posted this paper on a place called academia.edu. And that's kind of fun because I can kind of see what kind of responses I'm getting from my paper. So let me show you what that looks like. So this is called the analytics for academia. So I can see here that when I released my paper last Saturday, so I put it up after the talk, I can see I immediately got a whole bunch of reads here. And now this Saturday, I'm back to 0 here. So people have completely lost interest in my papers. But you can see that when I posted my paper, I got a pretty good bump. And I can also see where these views are coming from. So I can see my paper here, like this is my new paper, the electromagnetic wave, the ordinary wave. Someone from Cyprus and India and Canada and France, United States. We're looking at my paper. I can also see my other papers reviewed, like explaining the spectra of helium was viewed. Some people have viewed my profile. My most popular paper by far, however, has been explaining the spectra of helium, and I'm not sure why that is so popular. But of course, the funny thing is that people are reading this stuff, and you know, hardly anybody sends me any comments or emails or questions or anything. It's like they read it, and it's like they don't care. But I can see people reading my papers as a result. So okay, so let's see here. Yep, okay, so I think that was all the comments I had about responses that I got from my previous paper. So let's see here. Did anybody else have any comments here? I see that Cornelius has quite a few comments. He's saying that all waves have both longitudinal and transverse wave fronts. So I've kind of heard this argument, and it's like, I'm not sure it's terribly relevant because yeah, it's like even ordinary sound waves could be seen to have some kind of transverse components. But I don't think that's generally speaking what mainstream is talking about. Is that they're literally saying that electric field is moving at a 90-degree angle to the magnetic field, and so I'm not sure this is either here nor there to say that there's always this tiny bit of longitudinal transverseness. So he's saying it can be a single pulse, but because you are measuring it with an electron, which is a composite wave pattern, the amplitude may be sensed as it encountered each wave layer the electron is composed of. Because I'm not quite sure. I mean, they got a pretty good correlation between the pulse shape and the electron movement. Few cycles of each light when connected larger. The peak is the strongest and reduced. And did anyone else have any questions? We're kind of getting towards the end of our chat here, so that's wide open for questions now. Mitch, go ahead.
Thanks, Franklin. I just had a comment, or maybe it's a question. When you first were talking about your paper and your idea, you mentioned you were talking about inertia, and they have several questions out there in mainstream also that once a bullet is going so fast, it keeps going, and what keeps that going? I guess or the energy to keep that going, where does that come from? And I was just thinking about that a little bit. Would it really need any energy to keep going once it was going at a certain velocity? Because velocity is just relative, and to get it up, the acceleration, yeah, it would need energy. But once it got up to the velocity, does it really need anything to keep going? Because velocity is just relative anyway.
Well, I don't think it's the question of does it need energy. Obviously, it doesn't. The question is where is the energy stored, per se, while it's traveling? That's the question, is that you have this bullet, it's in the middle of the room. I mean, it's got energy, right? But where is it? I mean, if I were to, like, say, take a wind-up toy, and I wind it up, and then I take it across the room and I let it go, while the wind-up toy is in the middle of the room, I could say the energy was stored in that spring, right? There's clearly something storing the energy. Or if I were to, I don't know, to have a little car and I put gasoline in one end and then I move it to another location and I turn on the car, I could clearly say that the energy was contained in, say, the gasoline, right? But in the case of a bullet, it's going across. Okay, what is it physically about the bullet that allows it to store, like a battery, that energy and then deliver it to a new location? Okay. I think that's the question. It literally stores the energy like a battery, right?
And that is now that you state it that way, that is a good point, because since motion is relative, or since velocity is relative, if you took the velocity of as a point of view, or as a point of reference of the moving bullet, and then a stationary bullet, it would be like that one was the one moving. So that one should have energy to it, because as a frame of, according to the moving bullet, the other bullet is moving, so that bullet should have energy. So that is kind of a good question.
I suppose this also brings up the question of, if there's an ether, then there actually should be an absolute velocity, right? This is all this relativity stuff. I don't want to get too much into it, but one of the arguments about for etherists is that, well, if there is this physical ether, then you can declare an absolute velocity against that ether. And then you have to go, well, what about the MMX experiment? We don't detect the motion of the Earth. And then we have to start saying things like, okay, well, the ether is entrained so that the ether is moving about as much as the air in this room, which is not at all. So we would say for MMX, if you put an MMX experiment in here and you tried to measure the speed, you would find out the speed is 0, right? Because the ether is doing the same thing as the surrounding medium, right? Mm-hmm. But you can do certain things like the Fitzhugh experiment, where you have rushing water and that apparently appears to be able to drag the medium. That this appears to be a property that if you have a bunch of material in motion, that will actually cause the media, whatever it is, to also move with it, but it doesn't move at the same velocity. It strangely moves at, there's some formula that you can use, but it's not 100%. It's like an exponential thing. The motion, but you can detect the motion in those experiments, right? It's not like MMX where you don't detect anything. You can detect the motion of the water through these kind of interference experiments in the Fizeau experiment. So it's not like those kind of experiments can't work. And but once again, this is another challenge to the people who think there is no ether. If there is no ether, then how do you explain what's going on in the Fizeau experiment? It's like it seems like there must be a movable medium in there. And but to the relativist, that if you can establish an absolute frame of reference, then that kind of cleans up the math a lot. If you can establish, but it would seem that my own personal opinion is that the ether isn't trained, and therefore we sit in our own little ether bubble here on Earth, and that makes it hard to measure. And so other people have suggested that if you want to go see the motion of the Earth, you got to go send a space probe out of the gravitational field of the Earth, and but still orbiting like the Earth. Put it the opposite side of the Earth. Then you would in fact see the 30 kilometers per hour that Michelson Moreland were looking for, possibly. So
yeah, another complication, I guess, would be there's still, I don't think that there still would be an absolute reference, because it's hard to describe. In my view, it's hard to describe the ether as being stationary. I believe, like Glenn Borkert, that matter is always moving. Nothing is stationary, and especially the ether, which isn't slowed down by most material objects. It would be moving out. Every piece of ether would be moving all over the place. So there isn't. I don't know if you can really establish frame of reference even for the ether either, because it's constantly in motion.
Yeah, I would say that as an etherist, I'd have to say that there is no absolute frame of reference. The frame of reference is determined by the local state of your ether. If your ether is stationary and you're sitting on the Earth, then it's stationary. But in the absolute sense, you're still moving through a grid of space.
Actually, the evidence is from first order experiments like the Sagnac effect that the Earth rotates inside the trained ether.
Yes, it does. That's an interesting point.
So that the velocity of the local ether relative to a laboratory is not zero; it's the rotational velocity of the Earth. The spin at the latitude of the experiment. So it might be 350 meters per second instead of the 30,000 meters per second that Michelson-Morley experiments have been looking for. And that's why they didn't see it, because it's too small.
Yeah, that's interesting that we can detect the, let's see, we're getting some echo there, some new Jim there, that we can detect the, say, the rotational speed, the 24-hour day rotation, which is not that fast, but we can detect it. But we can't detect the motion of the Earth going through around the solar system. Now, generally speaking, this is called the Earth-centered frame. And this is actually, I believe, how GPS treats the universe. The GPS treats the universe as if the Earth were the center of the universe, spinning around a point in the center of the Earth, according to like all the, say, Doppler effects and whatnot. In order to get GPS to work, that's what GPS has to pretty much presume, which is kind of strange. And this is kind of getting into the Earth-centered universe people thoughts, but nonetheless, we have this this picture that if we think that there is a material ether, that if there was an absolute coordinate system, it would appear to be centered on the Earth. And then Copernicus would turn over in his grave because he, doesn't want to think that the Earth has a special spot in the universe, but the ether kind of says it does.
No, we're saying it's a bubble.
Oop, go ahead, Jim.
Yeah, it's not the ECI does not, the ether, the reference frame, the preferred reference frame for the Earth locally near the Earth. Yes, that's the ECI, but it's not infinite in extent. We have local ether going out to maybe 1 million kilometers, and then the sun's local ether becomes dominant, and it has its own bubble. So we're not trying to say that the ECI extends forever.
It might not. You'd have to send some satellites around with interferometers and check out to see whether the influence, how far the influence goes. We think the influence goes probably at least as far as the gravitational field goes. And I'm not sure how far these GPS satellites are out. Maybe I think they're relatively low Earth orbit.
The GPS satellites are about 20,000 kilometers, so they're still within the bubble.
The question is if NASA were to create a GPS system, but for the solar system, right? So that they could track the location of all their space probes. What kind of math would they have to use?
The sun's local ether is stationary with respect to the sun. It's the preferred ether, and that's also observed with interplanetary echo experiments.
So I'm going to mute you while I speak. There was just some recent news item that one of our space probes just reached interstellar space. So that's kind of relevant because maybe that's where the boundary is for the local ether bubble. All right. Well, I believe that we've come to the end of our conference here today. So I thank all the participants. I thank Draft Physics for reviewing our last talk, and he's going to continue covering that talk since he wasn't able to get through the rest of it. So I'm looking forward to that. And I also thank all the other people who sent me emails and sent me the experiments to address my challenge of measuring the electric and magnetic components of the EM wave and prove me wrong that the EM wave is not the same thing as an ordinary sound wave. It may be, it may be not. I just provided some ways of explaining some of the phenomenon that could allow that kind of explanation to exist. Now, whether it's true or not, I guess that'll be for history to decide. I'm just, as an engineer, just trying to find a way to explain things in a more physical sense. And since we understand how sound waves work, then it makes sense to try and explain these electromagnetic waves in the same sense. Could be right, could be wrong, but certainly it's not a completely crazy idea that you can immediately dismiss. So that will do it for this episode of the Science Chat. And you don't want to miss next week. Lori, who participated in this conference, will be giving a talk on the nature of light, specifically about the Planck constant. So you don't want to miss that. That will be next week. But that will do it for this week. We'll be